This demonstration introduces the graphical user interfaces in the statistics toolbox that are used for evaluating probability distributions. Working with probability distributions is a key aspect of using statistics for data analysis. They are helpful in tasks such as variability analysis, sensitivity studies, hypothesis testing, and parameter estimation and prediction. The statistics toolbox includes 3 GUIs as well as command line tools that make it easy to look at probability distributions, generate random samples from them, or fit them to your data. We'll discuss 2 of the GUIs briefly, and then discuss the distribution fitting tool in more detail. The first GUI we'll introduce lets you look at probability distributions and determine how their parameters affect their shape. To open this GUI, type dist tool at the MATLAB command prompt. This GUI lets you select which of the 20 available distributions you want to look at, and whether you'd like to view the probability density function or cumulative distribution function for the distribution. We'll look at the PDF for a normal distribution. You can change the mean and standard deviation for the distribution and see how its shape changes. This GUI is excellent for developing an intuitive understanding of probability distributions. The second GUI we'll introduce generates random samples from any of the 20 available probability distributions and displays the samples as histograms. It also lets you export the random samples to the workspace, which you can use to test hypotheses or models under different conditions. To open this GUI, type rand tool at the MATLAB command prompt. We'll create a normal distribution with a mean of 1 and a standard deviation of 2 and generate a 1 million element random sample from it. The GUI creates and displays this sample in about 1 second. We click the Resample button to generate another random sample and export the sample to the workspace. The remainder of this demo will show how to fit probability distributions using the Distribution Fitting Tool GUI. To open this GUI, type dfit tool at the MATLAB command prompt. The Distribution Fitting tool lets you fit 16 predefined probability distributions, or your own custom distribution, to your dataset. It makes it easy to pre-process your dataset, visually analyze fit quality, compare multiple fits, and evaluate fit results. The Distribution Fitting tool has several task buttons for creating, analyzing, and managing your distributions. Let's use an example to show how to analyze some data in the Distribution Fitting tool. We'll use data that represents a series of angular position measurements of an electronic throttle for an automobile. This data is contained in a 162-element workspace vector called throttle angle. We'll import this vector in the data window and create a new dataset within the GUI. From the data window, we can also choose whether to plot our data in the Distribution Fitting tool and alter the bin sizes of our data's PDF plot. Now that we've created a dataset, we can choose how we'd like to display it. The default display is the PDF, but there are other options available, including CDF, Inverse CDF, and others seen here. We'll use the default PDF setting. Our data looks like it may be normally distributed, so we'll try fitting a normal distribution. We do this in the New Fit window. We'll select the normal distribution and name it Normal Fit. When we apply the fit, it appears in the Main Axes window. Some fit results, such as the mean and variance, are displayed in the Results pane. A normal distribution doesn't represent our data accurately, especially near the mean. We need to find a distribution that can accurately model our dataset, which has a significant number of outliers and is heavily populated around the mean. Let's see if there are any other distributions available that might fit our data better. The T-location scale distribution is a robust distribution that can handle datasets similar to ours. We'll select this distribution type, name it T-location fit, and apply it to our data. The t-location scale distribution clearly fits our data much better than our original normal distribution. We'll remove the normal fit from our plot within the Fit Manager. Now, suppose we suspect that the outliers in our dataset result from a faulty measurement device that is used to obtain our throttle position data. We can specify portions of our dataset that we'd like to ignore using the Exclude window. We can specify these sections by setting numerical limits or via a graphical interface. We'll exclude the outliers in our throttle angle dataset graphically. Let's remove the outlying data points and leave the main section of data centered around the mean. Everything within the gray region is excluded. We'll name our exclusion rule Remove Outer Points, and then create it by clicking the Create Exclusion Rule button. We'll apply this exclusion rule to our normal distribution to see if the poor fit was caused by the outlying points. To do this, we'll go to the Fit Manager and edit our normal fit. We'll select Remove Outer Points from the Exclusion Rule drop-down menu and then apply the modified fit. In the Fit Manager, we'll reselect our normal fit so that it's plotted in the main axes again. Our normal distribution fits our data much better now that we've excluded the outlying points in our throttle data. The normal distribution ignores the measurements that we don't trust, so we'll focus on this fit rather than on the t-location fit. We want to make the normal fit available as a variable in the MATLAB workspace so that it can be used outside the GUI environment. We can do this by going to the Evaluate window and evaluating the PDF of our normal fit in the range where our data lies. We'll then export the result to the workspace as the variable throttle angle fit. The distribution fitting tool also lets you evaluate other functions, such as the CDF and survivor function. After finishing our analysis, we can save our dfit tool session for later use. When we load the file back into the GUI, it retains all information from the fitting session, including datasets and distributions. We can also automatically generate an M file from our dfit tool session. This is useful for preserving work or including it in other M files. This concludes the demo of the distribution fitting GUIs available in the Statistics Toolbox. For more information on these GUIs, see the documentation available from the Statistics Toolbox product page.